Okay, so welcome everybody. I directly give the floor as for welcoming everybody to Anja and to Donovan.
Yeah, thank you, Martin. So on behalf of the Prevent Waste Alliance, I would like to welcome you all to our Organic Waste Working Group's new webinar series. And it has got the thrilling and I hope for you also very interesting name of Let's Talk Biogas. And it's a series of various sessions which we're going to introduce later. But for now, a very warm welcome of my colleague Bert Wiebel from the Association of Chambers, who's co-chairing the Organic Waste Working Group. And from my side, Anja Schwedje from the German Environment Agency. And I happen to be also one of the co-chairs of the CCAC Waste Hub. And with us is also the CCAC Secretariat, Donovan Story, who's supporting us in our Waste Hub's work. And he's the waste expert as in CCAC. Donovan, please, the floor is yours for welcome.
Thank you, Anja, and yeah, a very warm welcome to everybody on this series on Let's Talk Biogas. We'll be having a number of webinar events coming up, which we'll introduce in a moment, but I just wanted to welcome those particularly that have come through the CCAC Waste and Agriculture Hubs, of which this is an event on that calendar. So welcome everyone. Really hope you enjoy the focus on biogas, amongst other things as well, over the next few months as we really try and unpick the opportunities and the potential of biogas, but then also, as you'll see today, really honestly discuss and confront a number of challenges which need to be successfully addressed in order to have biogas as a relevant and a very useful strategy to eliminate methane, of course, from the atmosphere and from GHGs, but also to create a positive use for particularly organic waste and food waste to support circular economies. So very happy to welcome everyone to the session today and to the series. Thank you.
Yeah, thank you, Donovan. And here's a short outlook of what we plan to do in the webinar series, Let's Talk Biogas. We are here now in August. It's the overview session, and I really hope that you will not miss the session just because it's the summer break. But there's more opportunity in October, November, and in early 2025, and probably more sessions to come. So the next session, the part 2 session, is hosted by CCAC, as this is a collaboration between Climate and Clean Air Coalition and the Prevent Waste Alliance. So Donovan, maybe you would like to say some words for part 2 and the particular focus which we have there right before the COP29.
Thank you, Anja. Yeah, one of the themes that you'll see today really is the regulatory environment and how it can either impede or facilitate successful biogas and circular economy approaches through biogas. And so part 2 will really look at that regulatory framework and where there has been successes in regulation and a policy environment which is conducive to successful biogas usages and also biogas production. And we'll look at that in a range of geographies as well, including the global north and the global south. And a number of us would know that, for example, the World Biogas Association is doing some very comprehensive work at the moment on common frameworks and common understandings of what are the most effective regulatory and policy environments for biogas. So we'll be exploring that particularly in the part 2 event in October of this year, and you'll hear more on that between this event and that event as well. Thank you.
Yeah, thank you, Donovan. And you see, part 3 is meeting local needs, and that means that biogas has different scales from industrial to relatively small scale local. And there's also a connection between the urban waste and what you generate in agriculture. So biogas is a relatively overarching topic, and that's what we're gonna touch upon in November, December in the part 3. And to give you a bit more of an insight on the agriculture side, I would also like to welcome the CCAC colleague Gregory Kohler, who is the agricultural expert of the Secretariat. So Gregory, maybe you want to have 1 or 2 words on the part 3.
Thank you, Anya. Yeah, happy to share a little bit. So one of the things that excites me about this series is not just focusing on the opportunities in biogas, but also some of the challenges. And as many of you will know, in manure management, there have been many challenges with applying biogas technologies, especially on local and smaller scales. And so in part 3, we'll be really focusing in on what some of the success factors are for biogas on, community level, and what some of those challenges are, and as Donovan mentioned earlier, honestly confronting those challenges and seeing how we can overcome some of those. So it'll be an exciting webinar as well, and yeah, hope to see many of you there.
Okay, thank you, Gregory. So early 2025 will be how to get it right technically. And we all know that there's huge opportunity in biogas, but there's also the possibility of leakage of methane or accidents and other really technical difficulties which we have to look after and get the operations right. So that's what we're gonna touch upon in part 4. So you have an overview over the Let's Talk Biogas webinar series as we laid it out now. And with that, I would like to pass the word to Martin again, who will introduce you to the housekeeping rules, and then we go right into the session with Fachverband Biogas. Martin, the floor is yours, please.
Great. Yes, thank you, Anya. So some housekeeping rules. We are recording this meeting. That's the first rule. So if you open your camera, if you speak, if you do an input, it will be recorded. And if you want to be 100% sure to not be recorded, you can always have the option to leave the session. And we will share the recording with the Prevent Waste Alliance working group and also with CCAC afterwards. When you're not speaking, please mute yourself. And also, when there are too many cameras, I think no, it's fine, but we don't want everybody to put on their camera, at least when people are speaking, giving individual inputs. If you have any questions about the presentations, feel free to just use the chat so that we can come back to your question after the presentations and we don't forget them. And last but not least, it's a thing which is a phenomenon which is increasing in the last months, artificial intelligence chatbots. They have names like otter.ai or somebody's person's note taker, and we noticed that they join our meetings, but we will remove them instantly when we see them because they don't comply with our privacy standards. So if you know that you come with a chatbot, please don't allow them to this meeting. All right, I will give you a quick overview of the agenda of today. So we are almost finished with the first part, which is the welcome meeting rules and the session outline. Then Donovan will give you a very short introduction on CCAC. And for those who joined the session and don't know what the Prevent Waste Alliance is, I will give a short introduction on the Prevent, and then we will have our 2 main speakers, Frank Hofmann from the German Biogas Association and Leidiane Ferronato Mariani from Istituto de CCAC, to give our main inputs, and hopefully we will have a good and fruitful discussion after that. All right, so now I give the floor to Donovan to give us an overview about the Climate and Clean Air Coalition.
Thank you, Martin. Just a very brief introduction as one of the co-hosts of today's event and the series as well. CCAC is UNEP convened coalition, which has been working in the space of short-lived climate pollutants, with, for us today, a specific focus on methane reduction, aggressive methane reduction efforts in terms of supporting the goals of the Paris Agreement. So we've been working in this space for over a decade now. We have around 88 country partners, coming up to almost 90 actually, and a relatively similar number of non-state partners. So we work in a very unique space of having state parties, but also having non-government organisations, other international organisations and associations, as well as the private sector as partners, and are involved in, for today's event, as an example, are involved in our waste and agriculture hubs in a very dynamic and effective way as well. And the focus is on short-lived climate pollutants, and today, obviously, with a key focus on methane, and these non-CO2 greenhouse gases are becoming increasingly recognised for their importance in keeping 1.5 alive, and certainly keeping climate change as low as possible, below 2 degrees. And we're starting to increasingly, I think, as a global community, discuss the role of non-CO2 climate pollutants and short-lived climate pollutants as a part of that, as being critical in our bid to avert catastrophic temperature rises. And so today's focus on biogas is very nicely related to our potential suite of solutions or approaches, particularly on methane mitigation, primarily coming from organic and food waste, but also obviously agricultural waste sources, and so on. Short-lived climate pollutants, we also focus on black carbon as an example, and tropospheric ozone, and hydrofluorocarbons. And black carbon is also very important because a lot of it comes in our fields anyway, particularly from the burning of uncollected and unserviced community waste streams, of which that waste could be put to much more productive means, and could also support circular economies, jobs, and in this case, energy production as well. So short-lived climate pollutants are very important to CCAC. We see them as being complementary to efforts of decarbonisation, which is proving to be a much slower process than we would have hoped. But we're very motivated to work in this space, given the greater attention to non-CO2 greenhouse gases, and particularly through our waste and agriculture hubs who are co-hosting today's event. We have a number of organisations that are doing fantastic work in this space. So it's really terrific to welcome you today and to be a part of this series, along with Prevent in particular as a co-organiser. So welcome. Thank you.
Great. Thank you very much, Donovan, for introducing CCAC. And for those who might have received the invitation through CCAC networks, you might not be aware of what the Prevent Waste Alliance is. It's an international think tank, but also a do tank. It was launched in 2019 by the Federal Ministry for Economic Cooperation and Development of Germany, focusing on waste management and circular economy, now with more than 500 members, most of them from the private sector, but also research institutions, civil society, and public sector institutions. Our work is mainly structured in 3 working groups. One is working on plastics, and they have many sub-working groups on specific topics. There's one working group working on electronic waste and batteries, and one on organic waste, and that is the one which is co-hosting this meeting today. It was established almost 2 years ago. But we don't only work on these work streams, but also on overarching issues, cross-cutting issues such as financing, digitalization, and behavior change. And as I said, Prevent is not only a think tank, but it's also a do tank. And one of the things we do together is implement pilot projects, cooperating with several funders. For example, we now started introducing the concept of black soldier fly in 3 countries in sub-Saharan Africa as a pilot project of the organic waste group. I would like to briefly share two highlights and news of the Prevent. One is about 2 webinars we are conducting with for Latin America. So if you speak Spanish, you're more than welcome to join. You don't have to be a member for it. The first one already happened at the end of June, and it was focused on organic waste, Latin America and the Prevent. But the second one will happen on the 5th of September and focus on plastics. So if you're interested, just monitor the LinkedIn page of the Prevent Waste Alliance, which we might also share in the chat, and you're more than welcome to join. And the other news is about our workshops on accessing finance for circularity. It's also a series. It's a total of 4 workshops. The first one will be the day after tomorrow, and the last one the 28th of August. And the day after tomorrow, we will share findings from an overview of the circular economy funding landscape. But that's only for members, unfortunately. So if you're a member, you should have gotten an invitation already to these workshops on financing. And if you didn't get invitations, but you're a member, then please check the Prevent Hub for the instructions. All right. I'm not sure if technically I should give the floor back to Anja to introduce the next speaker, but I think I can do it. We are very glad to have today Frank Hofmann of the German Biogas Association. Frank is one of the key experts on biogas from Germany. He's a specialist in the Department of International Affairs at the German Biogas Association. But he also worked for other institutions involving another very important German institute, which is the Institute for Biomass Research, or DBFZ, as we say in German. I believe I also saw at least one participant from DBFZ in the meeting here. But he worked for about 26 years on biogas, including planning of biogas plants, biogas reports, feasibility studies, consultation, and Frank studied energy and process engineering, but is also graduated as a consultant for biotechnological applications. So as I said, thank you. Great having you here, Frank. So I'm handing the floor over to you for an general introduction overview on biogas with some case studies. Please feel free to share your screen and start.
Thank you, Martin, Anja, Donovan, Bert, for the very warm welcome. I'm very pleased to be invited in this session today. I would like to start with an overview on biogas to bring us back from the basics to more advanced topics. So in the first half of an hour, I would like to go into some details of first introducing the German Biogas Association, then talking about biogas in general, advantages, opportunities, technology trends, which we see worldwide, bio-waste to biogas, biomethane, and flexibility are 3 topics which are guiding the development. I would like to explain a little bit an overview about the development of biogas in Europe, worldwide, Germany. Not least, but towards the end, I would like to explain to show you some examples from practice, which is often an important point to see how that functions in reality, and we'll end up with some conclusions. So first, explaining a little bit, some words about the German Biogas Association. We have about 4,700 members in our association. We are a non-profit NGO. We are mainly financed by the membership fees of our members. Most of the members are operators of biogas plants, technology manufacturers, about 500 companies providing components or turnkey projects, research institutions, many others. With the membership fees, we have enough salary for 40 employees working full time on biogas topics, and our main objectives are definition of legal frameworks, guidelines and standards worldwide and in Germany, information exchange, knowledge transfer, and advocating on European, German, national and regional levels to promote biogas. We have an international department with 6 persons working there. Here we are mainly trying to connect people to provide biogas know-how, to develop or to work in new projects on European level and worldwide level. We are supporting other biogas association in association partnerships, providing biogas know-how and biogas training. Those trainings are on the location abroad or in Germany, combined with biogas site visits, for example. In the end, we are cooperating with many international organizations. If you have the need in further information, consultancy, biogas trainings, you can contact me after this session. Let's start with some basics, biogas advantages and opportunities. Here I have a picture of a biogas plant. That's one example how it looks like, but there are many other examples as well. Just to bring us on the same page, on the same basic level, what are the components of an industrial-sized biogas plant? So in this session today, we will focus on industrial-sized. We already mentioned that there will be other sessions focusing on domestic and household biogas as well. However, industrial biogas plants, usually the potential for the biogas production is the feedstock. I have a dedicated slide on that, which I show in a minute. So the feedstock is the potential which is collected, transported to the biogas plant, collected, often a little bit pre-treated to make it available for the bacteria inside the reactor. In the main reactor tank, biogas is produced. It's filled with liquid, water and degraded material. This reactor tank is stirred, insulated and heated up. The biogas is produced in the liquid phase, stored often on top of the digester. There are other storage solutions available as well. However, the biogas is produced here in the middle, in the main processor. Biogas itself can be used in a gas engine, for example, to produce electricity and heat in a cogeneration process. It could be burned directly in a boiler to produce heat only, or biogas can be upgraded to biomethane. I will focus on that later. Biomethane can be injected into the natural gas grid or can be used as transportation fuel. There's a second element which is produced in a biogas plant as well, and this is the fertilizer. All minerals which are introduced into the process will stay into this process and in the end will be available as digestate, as fertilizer. So all nutrients will be available to be brought back to the fields as fertilizer. This is a picture from a typical digester, which is not filled. That's in the construction phase. We see here the wall, often concrete or steel, stirrer, which are very robust to stir the material. We have a heating system outside, an insulation system. We have a rooftop construction. In this phase, the gas storage is on the rooftop. With this slide, I would like to give you an overview about the general advantages of biogas and biomethane. One point is biogas is a form of renewable energy. We can produce electricity, heat, or transportation fuel with biogas, or it can be injected into the natural gas grid. Biogas is storable and flexible, which is different to wind and solar energy, for example. I will come to that in a dedicated slide. We have the chance for waste management, circular economy. On a political level, discussion with decision makers, it's often important to have business and job creation. In our association or in German circumstances, we calculate, for example, that there are about 10 jobs connected with biogas per megawatt electrical installed capacity. So it's a job creation, and rural development are important points. Production of biofertilizer, I already mentioned that. And today the focus will be on climate and environmental protection. We have several aspects that has to be taken in mind. One point, which is the core element for today's session, is the avoidance of methane emissions from stored organic material. So nearly whenever organic material is stored, waste, agricultural residues, or animal excrements, manure, for example, typically those kind of material will be degraded, and by that methane will be produced. If it's in open air situation like in landfills or in storages on the farm, methane emissions will occur. In a biogas plant, we have a closed system where the material is processed in this closed system. The methane emissions are very much limited, and by that, methane emissions are avoided, which usually would occur. I have some examples and calculation for this point in a later slide. Additionally, we have the substitution of fossil fuels, so the production of renewable energy, substitution of fossil fuels, the substitution of mineral fertilizer. Mineral fertilizer, usually the production is connected with much energy use and greenhouse gas emissions by that. So this is substituted as well. And then there are plenty of other environmental advantages like nutrient recycling, odor reduction, but I will just limit it to this because there are so many other things to say about the environmental advantages. Let's start with the potential. How is biogas produced? The feedstock is key. All organic material that can be degraded except wood can be used in a biogas plant. It comes from animal byproducts, liquid and solid manure, for example, vegetable byproducts, so typically harvest residues on the fields, on the farm. It can be produced from organic material, from industrial and commercial waste. Energy crops is only relevant in some countries, but not relevant in most of the countries worldwide. Biogas can be produced from bio-waste, from household level. I will show you an example in some minutes. Could be produced on mixed rate, but that's more demanding and challenging in separation of organic fraction from the mixed waste. Biogas can be produced from sewage sludge. So that is the palette of options how biogas can be produced. That is the potential of biogas production. Let's come from the basics to some technology trends that we are seeing worldwide. And I would like to start with biogas from bio-waste. So in many countries in the world, there are still many landfills, but we all know that landfills are connected with methane and other emissions. Often the landfills have sanitization problems, or the landfill is on fire, there are many particles produced, and so on. So there are many emissions in landfills. We have a loss of nutrients, so no recycling of the nutrients, and we have no energy generation from landfills. So the better options to use the organic fraction of waste is, probably you all know, composting, where the nutrients are recycled, but no energy production is occurring. There's an incineration possibility of organic waste, but in incineration we only have energy production. The ash at incineration usually has to be dumped on landfills. So only energy, but no nutrient recycling, while anaerobic digestion, or biogas is offering both options. We have the energy production and the recycling of nutrients. Feedstock might look like this. Here we have some canteen and market residues which are separated, collected. The biogas recycling waste to biogas saves greenhouse gas emissions from uncontrolled degradation and renewable energy production from waste. It's a substitution of mineral fertilizer, so closing nutrient and humus cycles. It's a soil improver, saves infinite resources. Phosphorus, potassiums are an important point, and it's an effective option to reduce waste volumes. If you are interested to get more details of that topic, bio-waste to biogas, the German Biogas Association produced a brochure, Bio-Waste to Biogas. You can find it on our webpage, or in my final and last slide, I will show you some QR code to download this brochure, which is available in several languages. Let's come to the next topic of this overview session. I would like to explain the difference between biogas and biomethane in a little bit more detail. So biogas mainly consists of methane, carbon dioxide, and some trace gases. If this is separated, methane from the other gases, then we are reaching biomethane, which is upgraded biogas. So biomethane can have purities above 97 up to 99% of methane, depending on the need, on the local need. Natural gas mainly consists of methane and some other gases. So biomethane is equivalent to natural gas quality. And because of that, methane can be used in the same usage routes that typically natural gas is used. Here we see a filling station where a CNG compressed natural gas car is filled. From the digester biogas with the upgrading system, now we have the whole route of opportunities, natural gas injection, after that filling station, gas heater at household level, for example, or cogeneration on the location where electricity and heat is needed. Further details can be seen in this brochure, Biogas to Biomethane. Let's come to the third technology option, which I would like to explain in a little bit more detail. And this is the fact that biogas is storable and the operation is flexible. We see in many countries in the world that with rising share of renewable energy in the electricity grid, there is a higher need to balance out the demand from the people, demand for electricity, and the production, for example, from wind and solar production. As long as we had in the past 20% renewable energy in the system, there was still much needed from the production of wind and solar, which is in green here. And there was a high need for additional fossil production of electricity to meet the demand. Here you see the daily demand of electricity. With 40% renewable energy, we already have the situation that there's more electricity from wind and solar energy compared to the demand. This can be stored. On the other hand, we still have these red areas where there's more demand of renewables needed. With 80% renewable energy, we have much energy, renewable energy production. However, there is still demand for flexibility. And exactly that's the role of biogas, for example, in Germany now. I will show you in some minutes. There are 10,000 biogas plants in operation in Germany. About half of them are producing electricity on demand. So in that kind of times of the day, where there's not enough wind and solar energy, biogas CHP, the gas engine, can be turned on. And that times where there's enough renewable energy from wind and solar, for example, the gas engine can be turned off and the gas can be stored. By that, biogas helps to balance the production and the demand of electricity production. An important point for future development as well. Having said that, I would like to show you with the next slide the general development of biogas in Europe and maybe some words about the development worldwide. Here's a graph from the European biogas and biomethane production. Over the year, we see in light green the biogas plants, 19,500, about that in the 2022, and the development of biomethane plants, 1,323 in 2022. We see the majority is still biogas, not biomethane, but the race and the development is stronger on the biomethane plant. The reason for that is that with biomethane, we have additional options to use the biogas. However, in smaller biogas plants, there's a tendency towards using the biogas directly without upgrading to biomethane, because for the upgrading facilities, we need additional investment. So as a general tendency, smaller biogas plants might produce or use the biogas direct. Bigger installations might think about transferring biogas to biomethane. In this slide, and again, it's from the European Biogas Association statistical report. Here we see the energy production in Europe per country. So total energy production from biogas and biomethane in the year 2020 was 223 terawatt-hour in that year. And we see nearly 100,000 of this, 100 of this 200 terawatt-hours are produced in Germany. But there are many other countries as well very active in the biogas market: Italy, United Kingdom, France, Spain, Denmark, for example. And we see a difference between how biogas is used. For example, in Germany, Italy, UK, the biogas is mainly used directly without upgrading. On the other hand, there are some countries, Denmark, for example, and partly France, where the focus is on biomethane, which brings us to the point of the next session as well, where regulation is explained. If a society, a government wants to have biogas, they can set the regulations in a way that, and incentive systems in a way that biogas will be produced. And additionally, driven by the regulation and incentive system, a government can decide how it is used. For example, in this form of biomethane, substituting natural gas in the gas grid, or in form of electricity production. That's always depending on the local situation of the country, which kind of use has the best greenhouse gas emission reduction effect, for example. So there are many experiences in many countries. Focus a little bit on Germany, because nearly half of all biogas is produced in Germany. Here's a graph. In blue columns are the amount of biogas plants in operation over the year, and in red is the installed electric capacity in megawatt in Germany. We can see from that there are decades of experiences. So it's state-of-the-art technology, nothing really new. Nearly 10,000 biogas plants in operation. The installed electrical capacity is nearly 6 gigawatt. So that's a substantial part. And if we have in mind that many biogas plants are providing flexible operation, 6 gigawatt for flexibility, this is a substantial part to balance out electricity demand and production. Worldwide, just a word about the worldwide development. We don't have really statistics, or at least I don't have studies about the worldwide production of biogas. If you see 20,000 biogas plants in Europe, we assume that in the range of 40 to 60,000 biogas plants are probably installed worldwide, but the focus is in Europe. And just some last figures about biogas in Germany again. I will not go into all details, but just additional points. The CO2 reduction by biogas in the biogas sector in Germany is about or above 20 million tons CO2 reduction. We have a turnover of 13.1 billion euro, which is very important. And biogas is a job creator, 50,000 jobs in the sector. Having said that, I would like to go with the next chapter of this presentation through some examples, explain that, how does it look in practice, what are typical examples, what biogas can do. I would like to start in Berlin, the capital of Germany, the city where I'm living. Here in Berlin, we have a separated bin for waste, separated organic fraction of waste. So we have several bins for glass, for packages, for example, and a green bin for separated organic fraction. This biogas plant in Berlin is processing 80,000 tons per year sorted waste from a household, produces 31 gigawatt hour energy, and we see several recycling loops, which I find very interesting, or probably are interesting in this sessions. From the waste, organic fraction of the waste from the disposal, trucks are collecting this waste, transporting it to the biogas plant where it's processed. Biogas is upgraded to biomethane quality, which is used as fuel for the fleet of this organization, which is collecting the waste. So we have a recycling loop. The energy from the waste is used to collect the waste in the trucks. And we have a second recycling loop. This is from the recycling material from the waste are processed in the biogas plant, brought back to the fields. The digestate is a little bit upgraded to meet a good quality, brought back to the fields. And by that, we have a recycling of the nutrients as well. In practice, this looks like this. This is the incoming waste, organic material. We still see that there are some plastics, for example, so the waste is pre-treated with some technologies to avoid plastics and materials which are not wanted. Those are two digesters, plug flow digesters, which are transporting the organic waste from the input side to the exit side. Here the biogas is produced, and here we see a picture of someone who is fueling the truck that collects the waste with biomethane. This is the first example I would like to show, and now we are coming to another example. That's pineapple production in the Philippines. In the Philippines, there are huge plantations of pineapples. The pineapples are processed indeed in this location. For example, there's a cannery, which means that the pineapples are cut down in a way that they can be used in a can. This can with pineapple are sold as food on the world market. And of course, there are residues from pineapple. We see a picture here, and huge amount of residues. In this cannery, they have 250,000 tons of fruit waste per year. If this material would be dumped on a landfill, there would be many methane emissions. Methane has about 20 times greater potential, global warming potential. We can discuss about the 28, depending on the time span, it could be above 100. However, there's a substantial part of, or methane has a substantial greater greenhouse gas potential compared to carbon dioxide. Calculating with 28 times, in this facility, about 212,000 tons of greenhouse gas equivalents are avoided each year by treating the material and not dumping it on a landfill. Additionally, there's a production of renewable energy which is used in this location in a gas engine to produce electricity and heat, which is used as process energy in the factory. By that, fossil fuels are reduced, substituted, which avoids about 50,000 tons of greenhouse gas emissions per year. In sum, just one factory avoids many greenhouse gas equivalents. And indeed, this project is substantially co-financed by the generation of CO2 emission certificates. So one important point of this facility is to produce those kind of certificates, sell it, and get additional revenue from those certificates. In practice, as a photograph, it looks like this. There are 2 biogas plants on different locations in the Philippines. Each has 2 digesters, here, this one and this, 4,000 cubic meters reactor volume each. There's an additional mixing tank for that. One biogas plant has 3, the other 5 megawatt electrical capacity. And typically, I showed you the example of pineapples, but there are other opportunities to use the fruits and juice production, the residues from that in banana, papaya, mango, mandarin production. There are many opportunities for similar projects. Which brings me to the third and last example. That's a biogas plant in Kenya. A company called Tropical Power is operating them. 2.2 megawatt electricity are installed, 2 megawatt thermic can be produced, co-generated from electricity plus heat production. In this case, they are producing on the farm maize. The maize is sold on the world market as food, but each colp of maize comes with residues, which can be seen here in this picture. That's the input material, the residues from the vegetable farm. And here we have a picture of the biogas plant, the main digester, a hydrolysis tank. They usually use maize, but as well residues from broccoli, runner's bean, French bean production. That is the typical input material for this biogas plant. I come to the conclusion of this presentation. Conclusion is biogas is an improved state-of-the-art technology. We have experiences since decades. In Germany, about 10,000 biogas plants are in operation. This point is very important. Biogas is not only energy production, not only electricity, heat, transportation, fuel, but it has many other benefits and revenue opportunities. It's storable and flexible, fertilizer production, waste treatment, recycling, greenhouse gas emission reduction. And in Europe, the combined biogas and biomethane production amounts up to 223 terawatt-hour, which is equivalent to the gas consumption of Poland and represents about 6% of the gas consumption of the European Union. Having said that, I thank you for your attention. Here are some QR codes to download the brochures, and I'm looking forward for the next presentation and finally for the question and answer session. Thank you.
Yeah, thank you, Frank. And I think this has warmed us up to understand more about the biogas sector. So thank you very much to show the expertise of the German Fachverband Biogas. And from you finished with your international expertise. And from there, we will jump now right to Brazil with a presentation on Brazil. Leidiane, please go ahead. I noted already the chat is very lively, but we will come to all your questions after we finish this presentation. So go ahead, Leidiane.
Okay, thank you. I will share my screen. Okay, are you seeing me? Is everything okay?
Yes, everything is fine.
Thank you.
Thank you, Anya. Hello, everyone. My name is Leidiane. I'm a consultant in the Instituto 17. It's a think tank that works in the SDG and the Sustainable Development Goals in Brazil. And now I'm also a CEO in the Amplum Biogas, a small consultancy company that me and my partner founded some 2 years ago. It's a pleasure to be here presenting and talking a little bit about the Brazilian biogas market to you. And I thank you for the invitation. To begin, I will start in showing some, let me think, let's see, it's working. Here, now, okay. This is the graphic that you can see the. Thank you, Frank, for explaining all the concepts, the technology, and some cases. And now it will be easy to me to present about the biogas sector in Brazil. And then in the last 10 years, the growth of the biogas market in Brazil has been constant and sustained. And now we have more than 1,300 plants in operation in Brazil, producing more than 4 billion cubic meters per year of biogas. And then in the last 5 years was a growing of 21% per year. It's really important, but obviously comparing to the quantity of biogas plants in Europe, we are really only starting. This biogas production, what we can see is quite diverse in scales, substrates, and biogas application, and also sure in business models. Considering that we don't have in Brazil a specific policy that gives us some feed-in tariff or something like it, each plant or each producer need to find the business model and the technology arrangement that fits for their energy demand. Then most of the plants, as you can see here, is using the landfill. The biogas most of the volume of the biogas in Brazil comes from landfills and are used in electricity. Is 60% comes from landfill and almost 60% is used to production of electricity. When we analyze the quantity of plants, the units, most of the plants are using substrate from agriculture, mostly from livestock. And also then 8% are using this biogas for electricity. It's considering the network for electricity that we have in Brazil, it's easy to generate electricity and commercialize it. Because of this is the big picture of the biogas sector in Brazil is, as you can see, is landfills and electricity, but we are increasing the use of biogas from wastes from industry and also from livestock. Here you can see the distribution of these plants in the the left map of Brazil. In the points with red is where we have more plants, and most of the plants are in the center, south of Brazil. It's because we have a region with more agriculture, industrial production, and also with more urban population, and also because we have more demand for energy and fuel. Comparing this to the pipeline network, it's something important to understand, because this is why we have more maybe difficult to use and to develop biomethane projects, because our pipeline network is concentrated mainly along the coast. This makes biomethane logistics a little bit difficult than Europe or than US. And then many projects in Brazil are transporting biomethane in compressed gas trucks, or also sometimes they try to make the use of this biomethane in the same plant. And but there are some projects, 2 or 3 now, that are already injecting the biomethane in the gas grid, and we have a good perspective for it in the next years. I will show some data about it. For now, we are 0.3% of renewables. The biogas is 0.3% of the renewables in the national energy matrix. We have a really important participation of renewable energy in the energy matrix in Brazil, especially in the electricity, but also when we see in the general matrix. And biogas is not so important as other like biomass, hydraulic, but it's increasing the participation. And why we believe in these the biogas? I work in the biogas sector for some years. It's because we have in Brazil the national vocation to work with bioeconomic biofuels, and then we have a huge potential. And this potential is entirely from waste and effluents, is considering waste come from agriculture, livestock, industries, urban area, and effluents from all these activities. And only considering this waste and effluents, we can achieve 100 billion cubic meters per year of potential. That is the national company that works with energy planning for the Ministry of Energy, is EPE. In I-17, Institute 17, we studied this potential model in the short term, and we consider that we have more than 11 billion cubic meters per year. Only to comparing, more or less, the data that I have is that Europe is near 20 billion cubic meters per year of biogas and biomethane combined. Then Brazil has a really important potential for biogas, but not only in volume that you can see here. This in the right of the slide, you can see the distribution of this potential, the 11 billion cubic meters. We divided it considering the quantity of biogas. Is most of this biogas can come from industry in the short term, most from sugarcane industry that has the higher potential. But when we analyze the number of plants, most of the plants biogas plants, the potential can be producing biogas from livestock waste, more than 20,000 plants in Brazil in short term. And the potential for decarbonization of these plants is most come from landfills, from the use of the residues from urban areas. Then it's important to understand it when we analyze this 11 billion cubic meters per year of potential. It's important to understand that the policies that are being development from the government can really need to consider this difference. When we need energy, if you need if you are focused only energy, the industry, the sugarcane industry, the effluents from this industry are the most important potential. But if you want to develop the agriculture, generate jobs, maybe the agriculture should be focus the incentives. But if we have the goal to reduce the GHG emissions and make it really the energy transition, the first focus should be the municipal solid waste. This seems easy, but in the end it make it really complex to think about policies in Brazil that really achieve all these goals and make the biogas market development. Focus on the biomethane sector. We now this application has gained momentum in the last 2 years. And as Frank explained, it's a gas similar to natural gas. And it's the focus of producers and investors because of the better financial return of the substitution of natural gas and especially diesel comparing to electricity, and because of the decarbonization demand, because of the hard to abate sectors that are now in Brazil are starting to demand this type of energy, the biomethane. Considering the growth, the Brazilian Biogas Association says that it's expected to reach a production of around 6 billion cubic meters in the next years. And now we have 6 plants generating biomethane in Brazil, producing 0.4 billion per year, and more than 25 plants in authorization process. Then this now is the trend in Brazil. Everybody's talking about biomethane because the return of these investments are better. Only to show, I'm almost finishing. Some of the biogas plants in Brazil, it's really diverse. We generate biogas from sugarcane industry, for swine production, for dairy production, landfills, industries, food and beverage industries, bio-waste, and because of this, we don't have a specific policy giving a direction to the development of the business. Then it's each company has to find a way to make this viable. And the conclusion then, Brazil is uniquely positioned in the biogas market because of the agriculture, the livestock sectors, and also because of the urban quantity of residues. And the climate, the tropical climate, also give good conditions for the anaerobic decomposition. And it could become a new productive chain connected to agriculture, industry, and waste management, also helping to make more efficient the production and with less costs and with, for example, with fossil fuels. In other words, Brazil biogas potential is not solely tied to energy generation, but rather to adding value to productive activities, assistance in waste treatment, and decarbonization. To finalize it, however, it's essential to emphasize that despite the efforts from many organizations and the government bodies, this energy source does not have a dedicated public policy like other sources have had in Brazil. The context is that we don't have feed-in tariff, and we have only just few policies dedicated to biogas in the national and state level. And the potential for decarbonization through waste and effluent treatment and for renewable energy generation for biogas is really unquestionable. And it's crucial to have a national plan and agenda for biogas and biomethane. The investors are looking for biogas business to invest, but more incentive support and a regulated carbon markets are needed to really realize the decarbonization potential that we have in Brazil. I'd like to tell you that it's important to understand that biogas is not only about energy or decarbonization, but also about diversity. In Brazil, we have this network, Women in Biogas, with more than 400 women in a group discussing and trying to empowering women, and also for the diversity in the biogas sector in Brazil. Thank you, Anya, and I give you my contacts here.
Thank you, Leidiane.